So the second part of division happens if the denominator is a binomial, or you can think of it as a sum or a difference, a quantity. You cannot, under any circumstances, just multiply by the radical. You must use the conjugate. It's that important that I just read to you. I'm going to say it again. If the denominator is a binomial, or if you look at it and you go, oh, that's a subtraction. Oh, that's an addition. Oh, that's a quantity. You cannot, under any circumstances, just multiply by the radical. You must use the conjugate. I know, we need to talk about what the conjugate is. The conjugate is actually super easy. You have to look at it and you have to say, oh, it's a subtraction, or oh, it's a difference, and use the other one. So let's use things you're familiar with. If I have x plus 1, then its conjugate oops, that got off. Then its conjugate is x minus 1. If I have 3 minus root 2, then its conjugate is 3 plus root 2. Whenever I multiply these, what happens? Let's do the first one. What happens if you do x plus 1 times x minus 1? 1 plus 1 minus. What did that look like? X squared minus x plus x minus 1. And then when I combine like terms, I ended up with x squared minus 1. It happens every time. Remember factoring difference of perfect squares? This is why we did it. So that now, when I need to multiply, so here's my example, 1 over 1 minus root 2. That is a quantity. We cannot just multiply by root 2 over root 2. We're still going to multiply by 1, and it's still going to be a hidden 1, but now we want it to be 1 plus root 2. If it's a binomial, then you need to use the conjugate. It's going to require us to FOIL. But remember this difference of perfect squares, right? Well, what's going to happen when we do 1 minus root 2 times 1 plus root 2? We're going to do 1 times 1 to get 1. Outers. 1 times positive root 2. 1 times negative root 2. There's your inners. Negative root 2. And then we're going to do negative root 2 times positive root 2. So we'll end up with a negative the square root of 4, but you already knew what that was going to be, right? In the numerator, sometimes we'll have a distributive property, sometimes we'll have an extra FOIL we have to do. In this case, it's times 1. So we don't have to have anything except for whatever our binomial, our conjugate. That's all we're going to have up top here. Now we're still not allowed to have radicals in the denominator, but look at what happens when you combine like terms. Positive root 2 and negative root 2, well, they make a 0. And what is the square root of 4? Yeah, it's 2. So I have 1 plus the square root of 2 over 1 minus 2. Oh, that's something I can definitely do. 1 plus the square root of 2 all over a negative 1. And we never leave a negative 1 in the denominator. We always shove it up into the numerator. And to do that, everything changes signs. So that negative 1 minus square root 2 is my final answer. That only works with a -1. If I had any other number here, then I couldn't do that. I would just leave it as a fraction. I'm going to work through another one, and then I will leave you number 5 to try on your own, and number 6 to try on your own. So let's work through number 4 together. Give it a start. So I'm noticing that it's a binomial, so I cannot, under any circumstances, just multiply by the square root of 3. I have to multiply by the conjugate, 4 minus the square root of 3, over 4 minus the square root of 3. In the numerator, it's a monomial times a binomial, so just a distributive property. 2 times 4 is 8, minus 2 times the square root of 3. Well, 2 times root 3 looks like that. In the denominator, we have a FOIL, 16 plus 4 root 3 minus 4 root 3 minus the square root of 9. Wait, the square root of 9, that's just a 3. And these guys, positive 4 root 3 and negative 4 root 3, they're going to add to 0. So that in this problem, 8 minus 2 root 3, all 16 minus 3 over 13. Can I simplify my fraction? Nope. So I'm all done. And that's my final answer. 8 minus 2 root 3 all over 13. Give number 5 a try. Come back and check your work. Alright, welcome back. I hope you did just fine. Check over your work. Make sure your FOIL process looks good. Remember that the square root of 25 is 5. And 1 minus 5 is definitely a -4. We always check our fraction to see if we can simplify. And in this case, we can't. So we can move to number 6. Now, hopefully the first thing you notice about number 6 is that we have a binomial in the numerator as well as a binomial in the denominator. It means that we're going to have a place where we have to FOIL and not just simply distribute in the numerator. So we'll have a double FOIL problem. The denominator is not just root 6. It's a difference, right? It's a quantity. So we cannot just multiply by square root 6. We must multiply by the conjugate, which in this case is 2 plus root 6. So multiply by that unsimple 1. When we do that, it'll be a FOIL process up top as well as a FOIL down below. 4 multiplications, a binomial times a binomial, or double distribute. 2 times 2 is 4. 2 times the square root of 6. So 2 root 6 plus right there. Now we need to do root 6 times 2. That's going to give us another 2 root 6. And then the square root of 6 times the square root of 6. The square root of 36, which we know to be just 6. And if you need that extra step where we actually write square root of 36, you should do that. In the denominator, we have another FOIL. This one is a conjugate pair, so we should see the middles drop out. We should see 1 plus, 1 minus this time. 2 times 2 is 4. 2 times root 6, so plus 2 root 6. Negative root 6 times 2, so negative 2 root 6, and a negative root 6 times a positive root 6 will give us a negative square root of 36, which is 6. Now we can combine like terms. Notice in the numerator, those are both positives. So when I combine them, they're not going to cause a 0. I'm still going to have a radical in the numerator, and that's okay. So up top, I have 4 plus 6, which is a 10. And when I add those, 2 root 6 plus 2 root 6, we would treat it like 2x plus 2x. So that would give me a 4 root 6. In the denominator, it was a conjugate pair, so we wouldn't have those radicals that they would intentionally add to 0. 4 minus 6 is negative 2. And we always check our fraction to see if we can simplify. And in this particular problem, we can. We talked a while ago about that heart method, right? If you have a binomial over a monomial, you can check the heart. And if all 3 pieces of the heart are divisible, then you have to simplify. So 10, 4, and 2. Not the 6, remember it's simplified, so it's a variable. So I'll say it again. 10, 4, and 2. Not the 6, it's a variable because it's a radical and it's simplified. The 10, the 4, and the 2 are all divisible by 2, so we should do that. 5 plus 2 root 6 all over negative 1. And we never leave a negative 1 in the denominator. We always push it up into the numerator, which means all the numerator signs change. So positive 5 becomes negative 5, and positive 2 root 6 becomes negative 2 root 6. And that is rationalizing the denominator. We'll definitely be working on this in class on Monday.